Hello everyone and welcome to this third interaction on chapter 4 quadratic equation class 10. In this video we will take up exercise 4.3. Now before actually going to the exercise, let's take a sneak peek of the exercise. Okay, so in this exercise we'll work on two methods, completing the square method and quadratic formula to find the solution or find the roots of the quadratic equation. Also, we'll understand the mathematics behind this completing the square method and learn a trick for the same. We'll rearrange some complex expressions into a quadratic equation and then solve them. And finally, we'll try to build our approach towards choosing the method to be applied in solving a equation. Now see, if the method is mentioned in the question, you have to apply that only. But if the method is not mentioned, you are free to choose your own method out of three. That approach, which method will be suitable for the particular equation, we'll try to build in this exercise. So let's begin and all the best for your endeavor in this exercise. Now the first question is, we have to apply completing the square method and find the roots of the given quadratic equation if they exist. If they exist, first we have to check whether the roots exist for the given equation or not. And as we know, in interaction 1 we discussed about the nature of roots. Nature of roots is given by the discriminant of the equation. Discriminant d is given by b square minus 4ac. In this case, b square minus 4ac comes out to be this 25. b is 7, a is 2, c is 3, minus 7 rather be. Okay, so b square minus 4ac comes out to be 25, which is greater than 0, so it will have two distinct real roots. Now comes the method, that is completing the square. Okay, so if we can recall from interaction 1 also, the introduction of the method, we introduced the method like we'll complete the square, as the name of the method is completing this. We'll complete the square with first two terms to get it in the form either a plus b whole square, a minus b whole square, by adding and subtracting b square of the identity. Adding and subtracting means we are doing nothing to the equation. Equality of the equation remains. After decoding b, we have to find d first, then by equating the square with other part of the equation, roots are found. This is the mathematics behind this completing the square. We'll try to understand it. Okay, so first of all, identity, to which identity we will complete the square. A plus b or a minus b is determined by this term. Second term here it is minus, so we'll complete the square to this identity, a minus b whole square. A minus b whole square, a square minus 2ab plus b square. Now see, this is a square, this is minus 2ab. B square we have to decode first, then add and subtract to complete the square. Now see, first of all, if the coefficient of x square is a perfect square, then it's okay, like 4, 9 and so on. We'll write the square of this whole term. If the coefficient here is not a perfect square, we'll take under root of that and then square both, like this one, under 2x whole square. This is our a, right, minus 2ab. 2 a is this, b we have to decode b to get. Now see, 2ab is minus 7x, right? So here in these two terms, x is there, 7 is not, so 7 we want, 7x completed. But by doing so, 2 under root 2 is extra, we'll need to cancel out them. Okay, we'll need to get rid of them, so we'll divide it by 2 under root 2. This is our b, right? So this is how we decode b, right? A square, a is there, 2a, b, we will equate this to this term, second term, and find b. This is b, so we'll square it, b square, one time added, one time subtracted. means we are actually doing nothing to the equation. Equality is maintained, right? Plus 3 is here. Then first three terms are the expansion a minus b whole square. A is under root 2x, b is 7 upon 2 under root square, plus the remaining this one. We'll solve it, simplify it. This comes out to be 3 minus 49 upon 8. Further on solving, it gives out minus 25 upon 8. We'll shift to the other side, right? Then we'll, to get rid of this square, we'll take under root on both sides. We'll take under root on both sides. Under root on both sides, here and here, right? So here square will be cancelled out, and here we will get plus minus 25 under root 25 is 5, under root 8 is 2 square under 2 under root 2. Okay, we have discussed this thing already, how this comes out to be. 8 is bifurcated into 4 into 2, 1 is perfect square, 4 is perfect square, under root 4 is 2, and under root 2. Okay, then we need to find x. Okay, so x is on one side, the remaining part will be transposed to right hand side. Minus 7 upon 2 under root 2 plus minus 5 under root 5 upon 2 under root 2. 2 under root 2 is LCM, 7 plus minus 5. In next step, this under root 2 is transposed to this side, goes to the denominator in division, and get multiplied there, right, this way. So you get denominator 4 and numerator 7 plus minus 5. So from here we'll get two values of x. 7 plus 5 upon 4, that is 12 upon 4 is equal to 3, or 7 minus 5, that is 2 upon 4, that is 1 upon 2. So these are the two roots. X is equal to 3 or 1 upon 2. This is the mathematics of completing the square, how we complete the square. Okay, now we'll learn a trick for that. If this thing sometimes looks complicated to us, then we'll also learn a trick for the same. How? Let's see. In trick, we'll first convert this equation to monomonic equation. Monic means where the coefficient of x square is 1, right? So how we convert it? We divide it by the coefficient of x square, whole equation. Coefficient of here 2, so we'll divide it by 2 throughout, right? Whatever we get, first two terms are written as it is. We get x square minus 7 upon 2x plus 3 upon 2 is equal to 0. So trick is this, that first two terms are written as it is. First two terms, x square minus 7 upon 2x as it is. Next, what we'll do, we'll half the coefficient of x, this 7 upon 2, we'll half this, half the coefficient of x and square it. So half of 7 upon 2 is 7 upon 4, right? We'll square it, add it, subtract it simultaneously, adding and subtracting simultaneously, right? Plus 3 upon 2 here. Okay, understood this? First two terms are as it is, and then we will do the half of coefficient of x, square it, add it and subtract it simultaneously, and then the remaining term, that is constant term of the equation, in this case it is 3 upon 2 is equal to 0. Now see, we have completed the square. These first three terms, a minus b whole square, a is x, b is 7 upon 4 whole square, and this remaining part, when on solving, simplifying it, 49 upon 16 plus 3 upon 2, further simplifying it, we'll take to the other side, 49 upon 16 minus 3 upon 2, 16 is LCM, right? 49 minus 2 8 is 16, 8 is 24, 25 upon 16. Further taking under root both side. Left x minus 7 upon 4 is equal to plus minus 4 upon 5 upon 4. To need x is equal to, we'll transpose minus 7 upon 4 to this side, we'll get 7 upon 4 plus minus 7, 5 upon 4. 4 is LCM. These are like fractions, so x is equal to 7 plus 5, 12 upon 4, or 7 minus 5, 2 upon 4, 3 and 1 upon 2, the value of x, right? So this is the trick, right? And the mathematics earlier. So whatever you find suitable or whatever is convenient to you, you apply that method, right? Let's let's take second part, that is 4x squared plus 4 under root 3x plus 3 is equal to 0, and we'll do it by the trick method of completing square. First of all, we'll check the roots if they exist by b square minus 4ac. B square minus 4ac comes out to be 0, which means that equation will have coincident roots. Okay, so let's solve by the trick method. First step would be to divide the equation throughout by the coefficient of x square, that is 4 in this case. We'll divide it by 4 throughout. Whatever we get, first two terms will be written as it is. Here, see, 4 cancels out by 4. We left with x square. Here, 4 cancels under root 3x. So first two terms as it is. Then we will half the coefficient of x. In this case, it is under root 3. Half of under root 3 is under root 3 2. Under root 3 upon 2. Half the coefficient of x, square it, add it and subtract it. Under root 3 upon 2 square minus under root 3 upon 2 square, plus the remaining third term, that is constant, in this case 3 upon 4 is equal to 0. So here plus, so a plus b whole square, we completed the square with first two terms to get it in the form of a plus b whole square, and we'll write it in this form, a plus b whole square. A is x and b is under root 3 upon 2. Okay, so first three term written a plus b whole square. The remaining terms are simplified. We'll get minus 3 upon 4. Okay, so when we square this, under root 3 square 3 and 2 square 4, and minus 3 upon 4 plus 3 upon 4, which will cancel out eventually. We are left with x plus 2 under root 3 upon 2 whole square is equal to 0. Taking under root, we are left x plus under root 3 upon 2 is equal to 0, or x is equal to minus under root 3 upon 2. Coincident roots, two equal roots. So that's how it works. We'll practice this trick method in further questions also, right? Now, let's move further. So here we have to apply the quadratic formula. Quadratic formula in question number 1. Find the roots of the quadratic equation in question number 1 by applying quadratic formula, right? So let's, same questions, we have to apply the formula in this. So what is quadratic formula? First of all, roots exist or not, we'll check by b square minus 4 discriminant. In first case is 25. Two real distinct roots exist, right? We'll solve it by the formula. In formula for the x is equal to minus b plus minus under root b square minus 4ac upon 2. Under root b square minus 4ac means under root d, discriminant. This is our formula. We'll apply here. Very simple actually. So x is equal to, just replace the b, a and c. Let's see what we get. Minus b is minus 7 plus minus b square, 7 square minus 4ac upon 2 into 2a, right? Solving it, we'll get minus minus plus minus under root 25. Already b square minus 4 is already known to us, that's 25, right? Upon 4. Further x is equal to, under 25 is 5, so 7 plus minus 5 upon 4. Two values, one time 7 plus 5 upon 4, one time is 7 minus 4 upon 7 minus 5 upon 4, that is 12 upon 4, or 2 upon 4, that is 3 and 1 upon 2. So see, actually applying a quadratic formula is much more easy than, much more simpler than by completing the square or any other method. But in case these terms are, numbers are smaller, then only we can apply it more conveniently, right? Let's take one more 2x square plus x minus 4 is equal to 0. So let's first check the nature of the roots. It comes up with 33, right? Means if it will have two distinct roots, and the formula is x is equal to minus b plus minus under root discriminant upon 2a. So just replace b, a, c with 2, 1, minus 4. Let's see what we get. On solving, x minus 1 plus minus under root 33 upon 4. 33 is not a perfect square. Okay, so let it as it is. We get two values of x. One is minus 1 plus under root 33 upon 4. Other one is minus 1 minus under root 33 upon 4. These are the two values for x. Okay, two roots of the equation. Next, 4x squared plus 4 under root 3x plus 3. Again, the discriminant for the equation is 0, means it will have two coincident roots. Apply the formula. Let's see what we get. We replace the value of b, a, c by the from the equation, and on solving we get this, right? 4 under root 3 minus 4 under root 3 upon 8. It will be simplified as 4 ones are 4, 4 twos are 8, minus under root 3 upon 2. The root for the given equation by quadratic formula, right? So so we practice the same completing the square and quadratic formula on same question, same parts, same equations. Let's see what next question. Find the roots of the following equation. So we are given expression. We convert first it to the quadratic equation, and then we'll find the. Now in this question we are not mentioned the method, whether it is completing the square or quadratic formula or factorization method. So you are free to use any method, whichever you feel is convenient for you, right? So x minus 1 upon x is equal to 3. X is not equal to 0 in this. Solving, we get x square minus 3x minus 1 is equal to 0, right? We'll apply quadratic formula, this one. Very simple actually it is for the small number, and we get the answer like this. Two values, 3 plus under root 13 plus 2 upon 2, or x is equal to 3 minus under root 13 upon 2. Okay, we'll just practice that completing the square method, trick method. First of all, now see it's already monic equation. Coefficient of x square is 1. So first two term as it is, x square minus 3x. Then coefficient of x will half it, 3 upon 2, square it, add it and subtract it. Okay, remember this step. First two terms as it is. After converting the equation to monic equations, first two terms as it is, coefficient of x square, half it, and then square it, add it and subtract it. And this is the remaining, the constant term minus 1 is equal to 0. So first three terms, x minus 3 upon 2 square, a minus b square. Okay, a is x, b is 3 upon 2. And simplifying this, we get 9 upon 4 minus 1. Further on simplification, we get shifting this to this side, and we get 4 ones are 4, 9, 13 upon 4. Further taking under root on both sides, we'll get x minus 3 upon 2 is equal to plus minus under root 13 upon 4, which will give us plus minus 13 upon 2. X will be shifting 3 upon 2 this side, 3 upon 2 plus minus under root 3 under root 13 upon 2, or this gives us two values of x, 3 plus under root 13 upon 2, or x is equal to 3 minus under root 13 upon 2. Okay, so we just for the sake of a practice, we applied this method, completing the square trick method and this quadratic formula, right? Both. Let's take one more. Yeah, so this is a bit complex. Like first of all, we'll simplify it to get the quadratic equation. Now see, x plus 4x minus 7 is our LCM, right? One is cross multiplied, one is multiplied by x minus 7, and this one is multiplied by x by 4 is equal to 11 by 30. Further, shift this to this side, 30 to this side. Open the bracket, simplify it. We will get the quadratic equation, which comes out to be 11x square minus 33x plus 22 is equal to 0. Okay. Further, it can be simplified. Dividing throughout by 11, we get monic equation x square minus 3x plus 2 is equal to 0. So one time apply the quadratic formula for this. X is equal to minus b minus of minus 3 plus minus under root minus 3 square minus 4 1 into 2 upon 2a, that is 2 into 1. So on simplification, we'll get 3 plus minus under root 1 upon 2. Under root 1 is 1. So x is equal to 3 plus 1 upon 2 or 3 minus 1 upon 2, that is 4 upon 2 or 2 upon 2. Yani, 4 upon 2 gives us 2, 2 upon 2 gives us 1. X is equal to 2 or x is equal to 1. Now similarly, we'll practice that completing the square trick on this also. First two terms as it is, half the coefficient of x, square it, add it and subtract it, plus or the remaining third term, that is constant term of the equation. First three terms gives us the identity a plus, in this case a minus b whole square. A is x, b is 3 upon 2, minus the remaining part. We'll solve it, simplify it rather, and we'll get 1 upon 4. Then taking under root to get rid of this square, we get x minus 3 upon 2 is equal to plus minus and 1 upon 2. Plus minus because squaring in both case plus or minus gives us 1 upon 4. So two values of x comes out to be 3 upon 2 plus 1 upon 2 or 3 upon 2 minus 1 upon 2. Further 4 upon 2, 2 or 2 upon 2, 1, 2 roots. So this is the way how this trick method works for completing the square. And formula is very easy to apply in case of small real numbers, but in case we get greater number real numbers, then quadratic formula may be a bit lengthy or calculation may get larger, right? So this is the first part of this, actually 4.3. We have one more part in which we'll deal the word problems, so which will be in the next class. Till then, keep practicing and work hard. Okay, I'm leaving you with the with a small positive thought for the day, that is means we should trust ourselves. Okay, think big, trust yourself and make it happen. And thanks for watching.